So welcome again, beautiful people, to my channel. So now we are doing physical science and Newton's laws or second law of motion. So we are just applying it in calculations. So now we have a question says we have a 10 kg box which is placed on the table. A horizontal force of 32 Newton is applied to the box. So now here is our force, good people, 32 Newton, and a frictional force of a magnitude 7 Newton is applied again on the box in an opposite direction there. So now they say draw a force diagram indicating all the forces acting on the box. So now remember, good people, we just going remember our force diagram indicates what the forces which are acting. So now we're just gonna represent it in with a not a force diagram but actually a free body diagram, because in your exams usually they ask for free body diagram. So we have a normal force here, and then we have again a gravitational force. This is force exerted by the surface on the object. So this is our normal force, good people, and here we have our gravitational force. So, and again we have an applied force here, good people, to the left, which is 32 newtons. So this is our applied force, good people. And then we have again frictional force acting in opposite. So remember, friction is always the shortest one compared to the applied force because it is smaller. So this is how we actually represent it on a free body diagram. So now again we are the question number 2 says calculate the acceleration of the box. So how do we find the acceleration there? We are going to use Newton's second law of equation there. So it's going to be F net is equal to ma. So now what do we do? So we are gonna add the all the forces. F net, remember, a number of forces there which are actually acting on our object. So we have an applied force there, good people. Remember, we only focus on forces which are parallel to the surface. So these are our forces which are parallel. So the perpendicular one we don't actually pay attention. So now we have a F a. So now our applied force plus our frictional force, good people. So here we are. So now is ma. But you must also remember that friction is negative. So we're just gonna do that here. So it's negative. Remember our friction, good people. Let me just write it with a red there. So now what do we do? We are going to substitute our forces. So our applied force is 32 Newton. So 32 plus our frictional force here, good people, is negative 7. So it's negative 7 because we choose left as a positive direction. So now we have our mass, which is 10, good people, 10 kg. So we have acceleration here. So they said we must find the acceleration there. So what do we do? Then we are just going to work it out, simplify here, multiply where we have. So now we just going to minus here. We know 32 minus 7 is actually 25, good people, equal to 10a. So then you divide all over by 10 because we are looking for acceleration. So we get our acceleration as 2,5 meters per squared. So remember also direction is important, is to the left, good people. Yes, it's to the left in the direction of our uh, force, applied force there. So now this is how you do it. Remember to subscribe for more of Newton's solutions, good people. Newton's second law calculations, good people. Enjoy your day. God bless you.